observability platform with Oracle Cloud Infrastructure. My name is Tijo Thomas, and I'm a cloud evangelist at Oracle University. In this lesson, we are going to look at the key services and capabilities of the observability platform and how it addresses the priorities of DevOps. We will start with looking into the top priorities that could be addressed with observability. Number 1, information systems end-to-end protection, which means maintaining the end-to-end security of all information systems, whether it could be the physical data center, networks, or applications. Number 2, understanding the internal workflow of systems. DevOps would require a complete understanding of the internal workings of their systems, and that would help them to choose the right metrics to monitor proactively. Maximize agility in application delivery. The ability to quickly deliver applications with having continuous monitoring to identify issues in the early stages. For example, finding performance issues with applications, and we refer to this concept as the shift-left monitoring. This process would monitor constantly for health checks and find performance issues early during the process. Accelerate MTTD or mean time to detection and MTTR or mean time to resolution. This is one of the top priority in how quickly to detect issues or the mean time to detect and how quickly to resolve them or mean time to resolve. Reduced cost for breaches and operations. DevOps would also need to introduce processes or workflows that would reduce the overall cost of any breaches and including operational efficiencies benefiting to that cost savings. With proactive monitoring and quick resolution, the overall cost can be reduced. Improve services and customer satisfaction. DevOps engineer would also look to improve cloud services with leveraging the datasets and metrics and consuming them with best practices which can all add values to the customer. Let's now look into the end-to-end workflow of DevOps and define observability in this architecture. DevOps practitioners are continuously making changes to their code, and it gets checked in or committed into the code repository. The code repo is a platform where you host the entire code, including any software archives. So it is really important to monitor these code repos, or let's say if you want to monitor the total size of this repository. The next stage is the build pipeline, and it is the stage where this code gets compiled and makes it ready for deployment. The build pipeline would also create necessary build artifacts. For example, the files created during the build process, the distribution packages, war files, logs, and reports. The practitioners would need to know whether the build is successful and get notified if there are any failures. And then the deploy pipeline is where the code is deployed into the target environment. If you are deploying a container-based application, it would pull an image stored in the container registry and deploy into the OKE cluster, or you could deploy as a compute instance or as functions, which is the serverless solution of Oracle Cloud Infrastructure. And similarly, there is always a need to monitor if the deployment is successful and get notified if there are any failures. Infrastructure as code and configuration management are two main components in this workflow. For example, having Terraform configs, you can specify the required plugins to install, the matching infrastructure service to create, or use Ansible scripts or Puppet manifest for keeping a consistent configurations across the systems. During this process, there are a number of nodes created and could also follow a number of CRUD operations like create, read, update, delete operations into the object storage, or it could be running a SQL database instance. There are observability services that lets you monitor such operations that are occurring in the environment. And once the application is ready, end users can connect using HTTPS over a web application firewall or through an SSH session using the Bastion service. Monitoring for connectivity is a critical step and helps operations to capture failures before the end users finds the problem. As we saw previously, the end-to-end protection of information systems is a top priority, so using services like Vault to centrally manage the encryption keys and secret credentials, having the right IAM policies, CloudGuard and vulnerability scanning for monitoring the security postures of the environment. So it is important to know the changes that are occurring in the environment and get notified for the major ones. All these requirements are achieved through an observability platform that have services for monitoring, notifications, logging, events, etc. And that tells us observability is a core platform for DevOps that enables for CI/CD, continuous integration, continuous deployment, capturing continuous feedback with testing, monitoring, and continuous operations. Let's look into some of the key services that are related to observability. Monitoring enables users to gain insights on cloud infrastructure and workloads with out-of-box metrics. Users can configure alarms with thresholds to detect and respond to infrastructure and application anomalies. Logging can ingest log data from hundreds of sources using the CNCF open source data collector called FluentD, which helps to collect logs like for audit, VC and flow logs that can be used for diagnosing security issues. You can quickly search and discover logs, which is based on Cloud Event Standards by Cloud Native Computing Foundation or CNCF, and logging can be integrated with other OCI services like streaming, monitoring, and functions. Application Performance Monitoring or APM provides a comprehensive set of features to monitor applications and diagnose any performance issues. OCI Notifications is a highly available, low-latency service that follows a publish-subscribe pattern that can send alerts and messages to Oracle functions, email, and also including Slack channels and PagerDuty. The event service tracks resource changes using events, and it eliminates the complexity of manually tracking changes across cloud resources, and you can respond to changes in near real time using functions, streaming, and notifications. The platform enables you to have observability across infrastructure environments, middleware, and application tiers, and so you can provide faster feedback to developers. Let's look into some of the core use cases of this platform. Monitoring to inform business decisions. With transforming the collected data, you can make it accessible for different audiences and help them make decisions. For example, sharing operations data upstream to analyze whether the reported values are high or low, or whether you're anticipating any operational changes, or determining the technology use that has impacted the reported numbers in a positive or negative way. Gaining insights into the environment. Observability is about instrumenting your systems with tools to collect actionable data to know when and why the issue occurs. OCI's observability platform provides you the right set of tools or the ability to build tools to quickly troubleshoot issues that are impacting end users. Proactive issue identification and notification. The platform offers the capability to identify issues proactively before it gets reported or before it impacts the resource, and have different communication channels for notifying users. Productivity and operational efficiencies with automation. You have the capabilities to automate tasks with also having to execute more number of tasks that are in high priority. To wrap up, we looked into the definition of observability in DevOps with an introduction to the key services and capabilities of the platform. So that's all in this lecture. Let's now get into some of the specifics of those services. Thank you for watching. Hello and welcome. We are going to learn about the monitoring service, some of its fundamental capabilities, and a service workflow to show how it is integrated with the notification service. Monitoring is one of the foundational services of the OCI Observability and Management Platform. The main purpose of the monitoring service is it enables you to actively and passively monitor cloud resources. Active is about being proactive or being predictive in monitoring, and passive is about reactive monitoring using real-time data collected from cloud resources. The service uses a concept called metrics that contains the data to be monitored, and then another concept called alarms to alert for any of the problems being reported. There are different ways you can access these metrics and alarm data. You can use the OCI Cloud Console, or using CLI, the command line interface, and using APIs. There are a wide range of dashboards that you can access metric data in different graphical representations, and these are accessible through a single pane of glass window. DevOps is about continuous integration and continuous delivery of your application. Monitoring service gives you the ability to monitor the end-to-end processes involved in a DevOps cycle. Let's now look into the concept of metrics. Metrics are logically grouped within different metric namespaces, and these namespaces are like logical collection of multiple metrics. You can see in the screenshot you have a metric namespace dropdown, and we have selected the OCI compute agent, and this namespace provides you metrics like the CPU and memory utilization of your compute instances. There are different types of metrics that can relay metric data. The service metrics are those metrics from OCI cloud resources. Custom metrics are your own custom metrics that can be published using an API called post metric data. Dimension is another concept in the monitoring service. You can use dimensions for providing filters to the metric data. Let's say if you want to filter the metric data by a specific resource ID of a compute instance, or maybe filter by the shape used by the compute instance, you can add multiple dimensions with a name value pair and access metrics based on those selections. The next field, as you see in the screenshot, is the time period that you select along with the metric. You can choose a start time and an end time to filter metrics within this period. Metric data is relayed as raw data points into the service, and then it is aggregated to make it presentable to the user. Interval and statistics are two different functions that are used to aggregate these raw data points. Interval is the time window you provide within the start and end time period, which will aggregate the data depending on the statistic condition. Statistics is another aggregation function. For example, you wanted to look the maximum reported value of the CPU utilization. Metric stream is defined as an individual set of aggregated data. Taking an example here, if you have 10 compute instances, and let's say we are using the metric for memory utilization, the data would represent 10 individual metric streams, and in this screenshot you can refer to the different colors in the graph section which represent each instance. In the console, you are provided with an option to aggregate these multiple metric streams into a single stream of data, and this capability is referred as one of the grouping function. Let's look into some of the metric namespaces specifically for DevOps. The OCI DevOps code repos is a namespace, and it gives you metrics to monitor the total number of code repositories, the number of push and pull executed on those code repositories, and also the total size of each repositories. The OCI DevOps build is another namespace, and it is used to monitor the build pipeline. For example, you can monitor the time taken by the build run, the number of times the build have succeeded or failed, etc. OCI DevOps deployment is used for monitoring the deployment pipeline. And here you can monitor the time taken for each deployment or the number of times the deployment has failed its execution. Application Dependency Management, or ADM, is used to detect security vulnerabilities in application dependencies. So there are metrics for vulnerability dependencies, and that are combined in a namespace called OCI ADM. Then we have the OCI Compute Container Instance, providing you CPU and memory in use, both in percentage and in terms of actual resources. Now, there are hundreds of metrics that are emitted from different cloud resources, and it becomes difficult to remember each and every metric. So this lesson is more focused on the concepts of monitoring service and referring some of the examples used in a DevOps process. Alarms is one of the core concepts in monitoring, and this enables you to configure alerts and notifications. The diagram here represents the workflow. You have configured a DevOps project. The monitoring service collects metrics as raw metric data. We then choose the metric namespaces for OCI DevOps build and OCI DevOps deployment to aggregate this data. There are 3 alarms created from 3 different metrics from these namespaces. The first one is the build execution time, and if it goes beyond 60 seconds, it should trigger an alarm. The second alarm is for reporting build success, and the third alarm for any deployment failures. When the alarm state changes from OK state to a firing state, or even from the firing state back to the OK state, it sends a notification message to the topic which has an email address configured as a subscription. There are also other destinations in the notification service, like for example, you can notify Slack channels, or sending to a PagerDuty, or texting an SMS message, and so on. Similar to the notification service, monitoring is also integrated with the OCI streaming service so that it can send this alarm data into a configured stream. There are multiple components involved in creating an alarm query. To define an alarm query, you must specify the metric, the statistic, interval, and the trigger rule. Alarms have different states once you have created them. The OK state means the alarm is not in a firing state. Firing means the alarm state has been changed from OK to firing. Reset is when the alarm is not detecting any metric firing, or maybe the metric is no longer emitted. Repeat is referred when the alarm is maintaining a firing status and you have configured to repeat notifications to those destinations. Suppression is another configuration used to avoid publishing messages during a specified time range. This is usually useful to suspend alarm notifications during a system maintenance time. To wrap up, we looked into an overview of the monitoring service, the key concepts of using metrics and alarms. That's all in here. Thank you for watching. Welcome back. Let's now learn about monitoring queries. Monitoring Query Language, or MQL, is a simple, powerful language that enables users to query metrics and create alarms based on specific conditions. There are two modes in the OCI console where you can create these queries: the basic mode or the advanced mode. MQL expressions are a set of components that use a syntax-based structure, and the main purpose of these MQL expressions is to search for specific metric data points and aggregate them. The queries in the form of expressions are visible only when switching into the advanced mode of the service. You will have to follow the MQL syntax, which will govern these expressions for querying metrics. So an MQL expression have a set of components. The first component is the metric. We saw metric is a measurement that is related to the resource in the query. The statistic is a function applied to convert a set of raw data points into an aggregated data. The interval is used along with the statistic function, and it is the time window at what intervals the data should be aggregated. Dimensions is an optional component, and it can be used as a filter for the aggregated data. Grouping function is another optional component, and it is also used for aggregation. And then finally, the comparison operations. It is used for defining alarms, and it is one another optional component. We will look at the query components in details with referring to a few examples. And these are some of the metric namespaces and metrics that are part of each namespace. Now, it is difficult to remember the exact name of each metric, but just try to understand the different classifications and the purpose of using metrics in a metric query. Each metric represents a unit. For example, the build success metric is measured in count, so it refers the number of times the build have succeeded. And the same way, build failures refers to the number of times the build has failed. The build run execution time is measured in seconds, and it is the amount of time taken by the builds. There are metrics for monitoring the code repository, DevOps deployments, and then the OCI container instance with metrics for CPU utilization and memory utilization that is measured in percentage. The CPU used metric is a metric that is measured in total virtual CPUs and memory used in total bytes of the memory that is in use. Interval is a time window used within a time range of the query. So what this means, for example, you have provided a start date and an end date for the query, and you wanted to look for the maximum reported utilization of a resource every 5 minutes. So you choose 5 minutes as the interval. The values provided for the interval would depend upon the specified time range in the metric query. There are more interval values supported for smaller time ranges. The interval can be specified through the basic mode or advanced mode. With the basic mode, you can choose 1 minute or 5 minutes or 1 hour. With advanced mode, there are further options, like you can provide a range like 1 minute to 60 minutes or 1 hour to 24 hours or even 1 day. Dimensions are optional qualifiers that can be added to corresponding metrics. Grouping function is another optional component. You can use to group or combine metric data by using grouping function. Statistic is one of the core components in a query. For example, whether a resource is absent or measuring the average or count or the minimum utilization of a particular resource. Comparison operators are used for defining alarms. You can specify if the statistic is greater than a value or equal or not equal to a value. Here are some example sample queries along with the syntax to use. The syntax of a basic query starts with a metric, the interval, which is in square brackets, and then followed by .statistic function. And all of these components are mandatory to form a query. An example shown is the build success metric. 5-minute is the interval and the statistic used is the sum. This query returns the total successful build pipelines completed at every 5-minute interval of the selected time range window. In the next query, we are using dimensions with providing a dimension name and a dimension value. In the example, we use deployment failure as the metric, the interval as 5-minute, dimension is the project ID with the value of the project's OCID followed by the statistic sum. This is querying for the total failures in the deployment pipeline in every 5 minutes. In the third example, we are introducing the grouping function. And using the metric CPU utilization, we are looking at the number of hosts with a utilization greater than 80%. This is also referred as a nested query, which means you have multiple embedded queries, and these are typically used with creating alarms. Finally, the last example, this is another nested query. We are nesting a grouping function inside the query. The metric in the example is the success rate, and we are looking at the number of availability domains with a success rate lower than 0.99. To wrap up, we looked into the monitoring query language expressions, the different components that form the query. We also looked into the syntax to be followed while creating monitoring queries. So that's all in here. Let's now move on to our next lecture. Welcome to this demo on monitoring service. Monitoring service is part of observability and management, and it enables you to actively and passively monitor your cloud resources. Let's look into how to navigate into the service and access some of the features. Log into Oracle Cloud Infrastructure Console and choose the region on the top right. Select the burger icon on the top left, click on Observability and Management, and then Monitoring. There are primarily two concepts in the monitoring service, the metrics and alarms. The left panel shows the sections where you can see the service metrics and also creating alarms with alarm definitions. In the service metrics page, you can choose the compartment and a metric namespace. A metric namespace is an indicator of a resource or a service or an application that is emitting the metric data. There are different metric namespaces available in the monitoring service. Let's now look into the metric namespace for the compute agent. An agent is a software that is installed on the compute instances and is continuously emitting metrics. There are different metrics collected and shown here, like the CPU and memory utilization. In this compartment, we have got 4 instances running. You can see the chart representation for each of those instances. The OCI compute agent would also provide the metrics related to the disk activity levels, like the disk read and write I/O, the disk read and write throughput, the network receive and transmission throughput, and the average system load along with the memory allocation stalls, which means the total number of times the memory pages were reclaimed directly. So going back up to the page, there is an option to select for aggregating the metric stream, and selecting the option would aggregate the metric data. And as you see, the chart has been updated with aggregated values. Dimensions are used as a qualifier or a filter. For example, you can choose to add a dimension and select an availability domain or a fault domain or a region or a specific resource. Let's select a resource display name here and choose the dimension value, which is the name of one of the instance, which is a Windows server. You can see the chart has been updated and showing just for that particular instance. Similarly, you can add multiple dimensions to filter based on your requirements. Let's click on the Metrics Explorer on the left panel, and the Explorer allows you to write queries using the monitoring query language. Choose the compartment. Let's select the namespace as the OCI compute agent, the metric name as CPU utilization, the interval as 1 minute, and the statistic as sum. Let's choose the dimension with the resource display name and the value with the name of the instance. Click on Update Chart. You can see the chart is updated, and also the query that we created is shown under the Query Editor section. The alarm status on the left panel shows all the alarms that are in firing state. Right now, we don't see any alarms being triggered, which means there are no alarms in firing state. There is an option to create alarms from here, which will take you to the alarms definitions page. Click on Create Alarm. Now, when creating an alarm, you would need to specify a metric, statistic, interval, and a trigger rule. Let's put a name for the alarm as resource down. Alarm severity as critical. The alarm body is an optional field, but you can add more details about the alarm that you're creating. You can provide tags for better tracking, which is again optional. Under the metric description, choose the compartment name, the metric namespace as OCI compute agent. Let's choose the metric name as CPU utilization, the interval as 1 minute, and the statistic as count. Let's choose the dimension name as again the resource display name and the value as the Linux host. The trigger rule is a condition. You can choose operators like greater than or equal to, which means if the CPU utilization goes beyond this threshold, it fires an alarm. For this demo purpose, I'm choosing the operator as absent. So if the CPU count is not detected, it would trigger an alarm. And the last section is about notification. How do you want the alarm to be notified? Choose the destination as the notification service, select the compartment, and select a topic. A topic is a channel used for sending notification to a set of subscribers. You have the option to create a topic here. For the demo purpose, I have created a topic with providing the subscription as email along with the email address. The selection of repeat notification here will resend the notification at specified intervals if the alarm is in firing state. The suppress notification will enable you to suspend the alarm notifications. Make sure you have enabled this alarm and click on Save Alarm. You can see the name of the alarm resource down and the state of that alarm is OK, which means it has not been fired yet. Let's go back to the compute service and shut down one of the instances that we selected for monitoring the CPU count. The instance is stopped now. Let's go back to the alarm definitions page of monitoring service. Click on the alarm that we just created. And you can see here now the alarm has been triggered. The previous state was OK. Now the state has changed to be firing. You can also click on alarm status, which will show the alarm has been triggered, the severity is critical, the trigger time, and suppression status. I have logged into the email that I've subscribed to the topic, and I can see now an email alert being sent for the resource down alarm definition. We will now look into some of the metric namespace and some of the metrics for the DevOps service. I have created a DevOps project in a different region and a different compartment. So we will be using the Ashburn region and then the cloud native compartment. In the service metrics page, there are several metrics that allows you to monitor code repositories or a build process or a deployment process. For example, you could choose the OCI DevOps build namespace, and you can monitor the number of successful build runs, the number of failures, the build run duration, which is the time taken to complete the build run execution, and similarly the build stage run duration. We don't have any data collected with the recent time, but we will create a build run and see if the metric is collected. But before that, let's define an alarm to monitor the build run. And so let's navigate to alarm definitions and create an alarm. We will create an alarm for the build execution time. Let's leave the alarm severity as critical. We will add an alarm body. We are not adding any tags. Under the metric description, choose the compartment. So we are using the Cloud Native compartment. The metric namespace is where we wanted to select the OCI DevOps build. We are not using any resource groups. The metric name is build run execution time. We will use the interval 1 minute and statistic as max. We are not using any metric dimensions. We will use the trigger rule operator as greater than with the value 1 and the trigger delay minutes as 1, which means if the build run exceeds more than a minute, it would trigger an alarm. Under the notification, we use the destination service as notifications, the compartment, and the topic. So the demo topic is different from what we used previously. So this topic is created under the compartment Cloud Native Comp. Leaving rest of the selection as default and making sure the alarm is enabled. And let's save the alarm. The status of the alarm is OK, which means it is not yet in firing state. So let's go to the DevOps project and create a build run. I have an existing project, so let's click on it. We'll click on the build pipelines. And let's click on the build pipeline for test. We will now initiate the build to run with clicking on Start Manual Run. We will leave the build run name as default. Click on Start Manual Run. Let's go back to the build pipelines and click on Build History. We can see the build run got failed and it has taken the duration 1 minute and 7 seconds. So that should trigger an alarm and we should get an email notification. Let's go back to the alarm definition page and see the status of that alarm. We can see the alarm is in firing state. And let's log into the email and see if we have received an email notification. The following email has been received. Going back to the service metrics, we will now look into some of the metrics of OCI DevOps deployment. With choosing the OCI DevOps deployment namespace, you can see the metrics like the time in accepted state, the total deployment execution time, the stage timeout, and finally, if there are any deployment failures. And these are different metrics part of the DevOps project. You can create alarms on any of these metrics based on a trigger condition. So that's all in this demo. Thank you for watching. Welcome back to this lesson. We will be looking at a demo on how to set up the notification service using the CLI. The notification service is used to broadcast messages to other distributed components through a publish-subscribe pattern. There are two main concepts in this service, the topics and their subscription. We will see how to configure those using the CLI, and then you can integrate with other OCI services for different notification purposes. So let's get started. I have accessed the Oracle Linux instance that we deployed earlier using the PuTTY client. First of all, make sure that you update the file permissions of the config file that we created while setting up the Oracle Linux instance. If you don't set that permission, it might show a warning message that this file is too open. So let's run the command to set that permission. The permissions are set. Now let's try to run a command to list all the existing topics in this compartment. A topic is defined as a communication channel used for sending messages to all its subscriptions, and it is part of a compartment. So before we list the topics, we would need to know which compartment where we are going to list the topics and know the corresponding compartment's OCID. So here is a command that would list all the compartments in the tenancy. The command is OCI IAM compartment list. The response output is in JSON and the different key value pair. One thing to note here is the different OCID for the tenancy and the compartment. The tenancy ID contains the word tenancy in it, and the compartment's OCID represents the one with compartment in it. So these two could be referenced to avoid any confusions with the OCID. And as you can see here, there are several number of compartments in this result, and it won't be an easy or a quick process to capture the compartment's OCID if you have hundreds of them. So we can pipe additional commands to this existing command and further filter the results and get the exact value of what we are looking for. Let's enter the commands first, and then I will explain each of them. The OCI IAM compartment list is the command that we used to list all the compartments. We are then using the JQ command, which is a command line JSON processor, and it is used to transform the entire JSON into a readable format, then passing an argument to match the name of the compartment. And just for example, we are using the name of the compartment as workshop trial. And then we use the map function that will iterate over an array of items which was processed by that JSON processor and returning those results into a new array. And finally, reading the first value in position of the key mentioned as ID. So I have executed the command, and you can see the result here stating the OCI compartment's ID, and you can compare it with the ID mentioned on top, which is the same. The same way, we can check the OCID for any other compartments, and so let's check the one for the My Demo compartment. We will now store the compartment's OCID in an environment variable using the export command, and so it would be easy to refer to that variable in our next set of commands. We will print the value of the variable compartment ID to ensure the value has been exported. And now we will check the list of existing topics in that compartment. The notification service starts with the command OCI space ONS, and then topic list followed by the parameters would list all the topics within that compartment. And there is only one topic being configured here with the name lab, and so we will be creating a new topic using the CLI. To create a new topic, use the command OCI ONS topic create, and then followed by the compartment ID, the name of the topic, and a description as required. We have now created a topic named as demo under the compartment. Take a note of the topic's OCID here, or we could run the command to retrieve that specific value. Let's run that command. Compare the value that has been returned with the value shown above. We will now export this value into a variable so that we can use it in the next set of commands. As we saw previously, we would use the export command here and export the value to a variable called topic ID. We will now verify by printing the value of that variable. Once the topic is created, you can add multiple subscriptions like the email, Slack channels, PagerDuty, etc. For this demo, let's create a subscription with the email. To create a subscription, you will use the command OCI ONS subscription create followed by the compartment ID. We have exported the compartment ID to a variable called compartment ID. And then the protocol, which is email in this case. The subscription endpoint, which is the email address where we want to send the notification. And finally, the topic ID. We have exported the topic ID into an environment variable. Once the subscription creation is successful, you need to log into that email address and confirm it. And finally, to test, we can publish a message to that email address. We can now see the notification has been received by that email address. So that concludes this demo of using the notification service with the CLI. Let's move on to the next lecture. Welcome to this lesson on logging service. In this lesson, we will look into the logging concepts, the different types of logs, how to search and view logs along with some of the required IAM policies. Oracle Cloud Infrastructure Logging is a highly scalable service part of observability and management, and it provides a fully managed single pane of glass window for all the logs in your tenancy. Now, to define log, a log is a first-class OCI resource that stores and captures log events that are collected in a given context, like security operations. The logging service provides a centralized management for all the logs in your tenancy, and it can aggregate all logs from sources like OCI services and displayed in a unified console. Logging provides access to logs collected from different OCI resources like the compute instances, virtual cloud network or VCN, object storage, etc. These logs include critical diagnostic information that describes how resources are performing and being accessed. As the log file contains sensitive information and that are relating to security, for example, the traffic flow patterns, user activity, authentication, the service provides a secure management for audit, infrastructure, database, and application-related logs. There are different ways you can access these logs. You can access and search using the OCI console, SDK, and REST API. You can run rule-based actions on log events like taking an action on specific log events. Logging service has a feature called Service Connector that will move logs to other destinations like monitoring. So you can create alarms on log events or moving logs into object storage or any other third-party tools. A log group is defined as a collection of logs stored in a compartment. So when you enable a log for a resource, you would also need to create or specify a log group. Log groups are logical containers for logs. Using log groups, you can streamline log management, like you can segregate the logs into different log groups based on various purposes. And so you can quickly navigate into the log for better results. Logs and log groups are searchable, actionable, and transportable. This means you can move the log groups, let's say from one compartment to another, and all the logs contained in the log group would move along with it to the new compartment. Using the log group, you can limit access to sensitive logs with enabling IAM policies. And so you don't have to rely on complex compartment hierarchies to secure your log information. For example, the default log group in a single compartment is where you store the logs for the entire tenancy. You then grant access to the compartment for log administrators with IAM policies. Let's say some projects contain personally identifiable information or PII, and those logs need to be viewed only by a selected group of log administrators. Log groups allow you to put such logs that contain PII into a separate log group and then use IAM policy to restrict access to all, but providing access to a few log administrators. Logging service classifies logs into three different types. One of the most important log type in a security context is the audit logs. Audit logs are log events emitted by Oracle Cloud Infrastructure Audit Service. These events are REST API actions executed by any OCI resource like a user or a cloud service. These logs can be accessed from the console and available in the audit page under logging service. The second category of logs is the service logs. These are logs emitted by the native OCI services like the DevOps service, API gateway, object storage, VCN, etc. Each of these services has got predefined logging categories that you can enable or disable on your respective resources. The third type of log is the custom logs. These are logs that contain diagnostic information from custom applications that are running on Oracle Cloud Infrastructure or other cloud providers or even resources running in an on-premises environment. Custom logs can be ingested through the API or configuring the unified monitoring agent. Let's look into some of the concepts of logging service. Service log category. OCI services provide log categories for different types of logs that are available for resources. For example, the object storage service supports log categories like the read and write access events for storage buckets. The read access event captures all download events of that bucket, and write access events captures all write or upload events on that bucket. Each service can have different log categories for resources. The log categories for one service is independent, which means it has got no relation to other log categories of another service. The Service Connector Hub is a feature that allows you to move logging data to other services in Oracle Cloud Infrastructure. For example, you can use the hub to move the log data to monitoring and set up an alarm, or sending log data into databases or object storage for archive purposes. The Unified Monitoring Agent is a fully managed agent, and it is used to ingest custom events from your applications. Logging service uses the Fluentd-based agent, which is an open source data collector based on a Cloud Native Computing Foundation CNCF project, and it can be used to configure to run on compute instances for ingesting logs. The agent configuration page of logging service provides the configuration for this unified monitoring agent, and it specifies how the custom logs are to be ingested into the logging service. Logging service also provides features to view the filtered log data. You can visualize the data with chart widgets. You can choose stacked bar chart or pie chart, donut type, or line chart. The chart can be updated with choosing a time interval and also selecting a logging field to group the results. The log data that is searched, filtered, or visualized can be auto-refreshed for every 5 minutes or 15 minutes to view the most recent logs in real time. We will look into a log content generated by the OCI DevOps service. Service logs for DevOps project can be enabled through the OCI console. You would need to choose a compartment to store the log, provide a log name, a log group, and a retention period, which is between 1 month to 6 months to store the logs. Here is an example of the deployment log. The log construct is in JSON and it contains certain fields. The spec version is the schema version of the OCI logging service. The type, which is the category of the log, some of the possible values are build or deployment. The source is the name of the project where the log is associated to. It could also be an OCID. For example, the OCID of the build pipeline to which the log belongs to. Subject is the OCID of the target resource where the deployment is getting executed. Some of the possible values here are an instance, function, or a cluster. ID is a random UUID and it is unique to each log entry. Time is when the log was generated in the DevOps service. The next set of entries is contained within the section Oracle. So we could also refer as oracle.logid, which is the OCID of the service log object. Log group ID is the OCID of the log group. Tenant ID is the OCID of the tenancy. Compartment ID is the OCID of the compartment that the log group belongs to. Ingested time is the time the log was ingested by OCI logging service. The next few entries are within the data section. So data.deployment ID is the OCID of the deployment for which the log message is associated. Deploy pipeline ID is the OCID of the deployment pipeline. Deploy stage ID is the OCID of the deploy stage. The message contains the DevOps service log message. Data producer is the producer of the log message. It can be produced by the DevOps service code or by scripts run by the customer during the deployment. Once the logs are collected, the next step is to search the log that you're looking for. OCI logging service provides a powerful search engine tool to filter indexed logs through the console, CLI, or APIs. You can search logs based on custom queries. There are multiple filtering options. You can filter values by log fields, search by a text or a keyword, or filter by time intervals. Each log entry can be explored in details. You can find these details with expanding the log line section and view the entire payload, which is structured in JSON format. You can also access the before and after view, and that shows the exact proceeding of the log entry along with the successive logging lines in the log object. And finally, you can export these search results based on the filtering criteria into a JSON file. There are some IAM policies required to gain access into the logs. To manage log groups or objects, the following allow policies can be created for each group. In these three examples, the policies are created for groups named as A, B, and C. We use the verbs use, manage, read, and that is applied to the compartment named as X. To allow instances to push the logs, the instances need to have access to a configuration from the compartment. The log content controls this permission, and in this example, it is applied to a compartment X which is having those configurations. To view logs in the Search console, the following allow policy is required. These are two policies that are required to allow the group to read the log group and contents of the index logs at the tenancy level. Let's look into the end-to-end service flow of logging service, starting from collecting and managing the logs from different sources. There are different types of logs collected: the service logs from OCI Cloud Services, audit logs, and then custom logs from your application, security relevant logs which are collected and ingested using different methods. The second stage is where you gain access into the logging service, search and filter for the logs that you're looking for, and run analysis based on the search results. In this stage, you would also configure Service Connector to send the logs to other services. In the third stage, you can take actions based on the previous stage. You can write into the streaming service or invoke an Oracle function as an action, or you can write into an object storage bucket. To wrap up, the logging service provides a centralized location to manage logs. There are three types of logs: service, audit, and custom logs. These logs can be searched, filtered, and analyzed using the OCI console, CLI, or APIs. And finally, we looked into some of the IAM policies required for accessing the log events. So that concludes this lesson. Thank you for watching, and we'll see you in the next lecture. Welcome to this demo on custom and service logs of the logging service. We will be looking at enabling the service logs for the DevOps project and creating a custom log for one of the compute instance. So let's get started. I have logged into the OCI console with selecting the region as Ashburn. And let's now look into how to navigate into the service and walk through some of the features. Click on the top left burger icon, Observability and Management, and then click on Logging. You can see different navigations on the left panel. With clicking on search, this takes you to the search UI. You can see all the saved searches with clicking on save search. The logs, where you can create custom or service logs. The log groups that you've created. The agent configuration for your custom logs. Service connector to transition your logs into other services. And then the audit logs. Let's click on log groups. Log groups are logical containers where you store your logs, and that will allow you to manage and organize your logs. I have a few log groups created here. So to create a log group, simply click on Create Log Group. You can provide a name, a description, and optionally you can add any tags which will help you to organize and track resources. In this case, I have already created a few log groups. We will be using those log groups in this demo. Let's now click on Logs. The Logs page is where you can create custom logs for custom applications, or if you have an on-premises environment, you can create custom logs, or you can also enable service logs from different services of Oracle Cloud Infrastructure. To enable service logs for DevOps, click on Enable Service Log. Choose the compartment from the drop-down. Select the service as DevOps. You can choose the resource, the name of the project that you have created. Choose the log category, which is DevOps logs. Provide a log name and click on Enable Log. I've already enabled a log for my DevOps project, and if you try to create or enable log for the same resource, it will throw an error. So let's cancel this and we will look into the log we created for the DevOps project. To see the logs that we created for the DevOps project, make sure you choose the right log group. And as you can see, I have created a log with the status active and the service is DevOps with the category of DevOps logs. We can now look into the log entries which are collected by this log. There are no log entries for the recent period of time, so we will update the custom time range. You can explore the log through this UI, or you can explore using the log search UI. We will filter by time with providing a custom start date and end date. And as you can see the error message, you cannot choose a period which is longer than 14 days. So we will try to choose a time within the 14-day period. The log data for that period has been shown. Now if you want to use custom filters, you can use data dot, let's say, producer, which is the DevOps service, using a comparison operator and then choosing as DevOps service. Let's expand one of the log. And the log entry is in JSON format. You can see the deploy pipeline ID, the deployment ID, and the respective message. So if you want to search with the deploy pipeline ID, you can simply copy the value and add it as a custom filter, or you can click by filter matching, and it will show all the log entries that contains that deployment pipeline ID. And as you can see, the filters have been added. You can always add custom filters based on your search criteria. And finally, we can then visualize the data in a graphical format. You have the option to choose a stack bar chart, pie chart, donut, or line. You can choose an interval based on your selection. And you can also group by different fields, for example, by choosing the OCIR ID of any of these workflows. And with scrolling down, you can see there are 33 records found. You can expand the section to see when the records was created. Let's now look into custom logs in the log section. Creating a custom log is a two-step process. you would need to create a custom log object first, and then second, create an associated agent configuration for that object. In this demo, we will be looking at enabling custom logs for an instance, and logging provide an easy mechanism to enable and manage the agent for a set of supported operating systems. You can enable the agent directly when creating the instance. So first of all, let's navigate to one of the instance and check the custom monitoring plugin status. I'm using a different region and a compartment where I am enabling this log. I am using an Oracle Linux instance with the host name CLI, and we will be using /var log message as the custom log to collect. Click on the instance and then on the Oracle Cloud Agent tab. You can see the custom logs monitoring agent is enabled and it is running. We will now create a dynamic group for this instance, which we require with the agent configuration. We will use the instance ID and the value of the instance OCID. You can also add multiple instance ID to collect custom logs from those instances. We will use only one for the CLI instance, and so let's proceed to create. We are now ready to create the custom log and its agent configuration. So let's navigate back to the logging service. Click on Create Custom Log. Provide a custom log name. Choose the compartment and then the log group. And then click on Create Custom Log. The next step is the agent configuration. You can choose to create the agent configuration now or add the configuration later. Let's create the configuration with providing a configuration name. Choose the compartment and choose dynamic groups under host groups and then the dynamic group that we created previously. You have the option to create policies for the instance in the dynamic group to use the logging service. So let's proceed and click on Create. Under the agent configuration, we will need to specify the log that we are going to collect along with the log file path. We are using an Oracle Linux instance, so we would use the input type as the log path. We will specify a name as messages. And in this example, we will use the var log messages as the log file. Verify the log destination with the right compartment, the log group, and the log name, and click on Create Custom Log. You can see the log that we created under the specified log group. So let's go into the log group and click on Demo Log Group and click on Logs. You can see I have my CLI instance log, which is a custom log type, and the status is active. It will take a few minutes to start ingesting the logs, which we can see on the Log Explorer Search UI. I have now navigated into the Log Search UI, and let's try to create a search criteria and look for the specific logs from the CLI instance. Click on the field Select Logs to Search. We will look for the compartment. The compartment is My Demo. We will select the compartment, but let's not add the compartment into the search, which will also add the service logs into the search. So we will remove the compartment. And in the compartment, there are a few log groups. So we will select the demo log group. We will not add the log group into the search criteria. In the logs, we are looking at My CLI instance log, which we will add into the search. And click on Continue. The logs are now populated. We can now expand each log entry to view the details. The log details have the specific log message, the compartment ID, the ingested time, the instance ID, log group, log ID, the source, which is the CLI, the subject, the log file path, and then the type of the log, which is the custom log. The before and after view shows the log entries that were reported before and after this log message, and it makes it easy to troubleshoot, to look into the traces, what happened before and after the log message. We could also refer to custom filters, and with choosing data.message, you can see the list of all messages that are collected, and you can filter based on your search requirements. You can also save the search or create a service connector to transition the logs into other OCI services like the monitoring service, logging analytics, etc. So that's all in this lecture. Thank you for watching. Welcome back to this lesson on event service. In this lesson, we will have a closer look into some of the key concepts and features, the event types related to DevOps, along with an end-to-end workflow of the service. Let's start with an overview of the service. Oracle Cloud Infrastructure, or OCI, consists of several infrastructure cloud services that enables you to build and run a wide range of applications and services in a highly available hosted environment. There are more than 80 cloud infrastructure services that produces events along with more than thousands of different event types, which you can then configure one or more rule conditions to trigger actions on any of them. OCI Events is defined as a service that allows you to create automation based on state changes of resources throughout your tenancy. And so with using events, you can enable your DevOps teams to automatically respond when a resource state is changed. An example would be you can send a notification to the team or trigger a function or script to take the next set of action. In a DevOps project, code repositories are one of the key components in a CI/CD workflow, and it helps you to store or host the source code, including any software binaries. Developers are continuously committing code changes into this repository. And so, the OCI DevOps service emit events that are related to the changes happening to the code repositories. The next stage is the build. The service emit events which could be related to the build process, the build run, or staging, etc. Or it could be with the deployment stage. Events are generated with several operations within the deployment pipeline. OCI Event Service generates events for such service operations, and it is in the form of JSON files that carries information about that specific operation. Some of the operations indicate the changes occurred within a resource. For example, it could be a create, read, update, delete operation, or call it as a CRUD operation. Or it could be a lifecycle state change of a resource. You can get visibility across the full development lifecycle with a history of the source commit through build, test and deployment phases. There are also system events generated that could be impacting a resource. An event is emitted when a backup completes, or if the backup operation fails, or when a compute instance is created or deleted, or let's say a file in the object storage bucket has been added or updated or deleted. You work with events by creating rules for a resource type and then restricting further by defining additional filters or tag names that match only certain events. And so these rules can be referred as customer-defined rules. Rules should also specify one or more actions to trigger when the event occurs. Actions can include like sending an event to the streaming service, which is used for ingesting and consuming high volume of data streams in real time. Or you can invoke an Oracle function, which is the serverless platform that lets you create, run, and scale applications without managing an infrastructure. Or it could be sending to a topic with subscriptions of the notification service. So to summarize what we covered so far, there are three main concepts in the event service. Number one is the event. Event is a structured message in JSON format, and it represents a change in an OCI cloud resource initiated either by the OCI system or executed by a user. Events are represented as well-formatted messages that defines what is the event, where the event is originated from, and other metadata that you can use for analyzing the activity. The next concept is the rules. A rule is another JSON object or configuration filters that you can create and subscribe to an event type and then trigger an action when that particular event occurs. Rules can filter all incoming events with one or more field values, and then based on the rule definition, you can decide what actions to take on that event. The third concept is actions. An action is specified for the rule to trigger when the filter finds a matching event. And so, actions are those responses that a user would define when an event rule condition is matched. Rules can have one or more actions defined to be executed when they are triggered. There are predefined set of actions that you can choose to be executed. As we saw previously, you can use services like the notification service, streaming, or Oracle functions to create actions. Let's take a deeper look into an event. An event is a structured, lightweight message that denotes the change in a resource. Events have a derived context with a structure, and it is guaranteed to be actionable. An event can be a user-initiated CRUD operation, like an object storage bucket is created, or a bucket is updated or deleted. It could also reflect a lifecycle state change in a resource, like a compute instance is stopped, or the instance is launched, or a backup is starting, or it could be an OCI system event, such as a hardware failure. So what are the constructs that forms together an event? Each event has an envelope that is the container for all event messages, and it follows the Cloud Event Standard format. This envelope includes the event source, which is the OCI service that generated the events, such as the DevOps project, object storage, or compute. It also includes an event type and a timestamp for when the event occurred. The event also have an inner payload that contains the service-specific data to describe the change occurred in the resource, including any tags that are associated to the resource. Let's look into some of the event types of the DevOps service. Event messages use a combination of an event type and a data payload from the resource to identify state changes. So essentially, event types are organized by the service and by the resource type. There are several event types in the DevOps service, and for the resources that are part of it, like for the DevOps project, deployment artifacts, code repositories, connections, the target environments, build pipeline and stages, build run, trigger, and finally for deployments. For example, with looking into the build pipeline, there are different events for each operations. Like the create build pipeline begin is when a build pipeline creation is initiated, and create build pipeline end is when it gets complete. Similarly, when a pipeline is updated or deleted, The service provides you events from the time the task was initiated and then it was complete.
Application Dependency Management, or ADM, is a feature that automatically discovers and maps dependencies between different components of your applications. A knowledge base is a key concept in ADM, and these are some of the events related to the knowledge base. For example, there are event types with creating, updating, and deleting knowledge base. A vulnerability audit describes the vulnerabilities of your applications and its dependencies. Similar to the knowledge base, there are event types with creating, updating, and deleting vulnerability audits.
What does an event look like? Here is an example event which is in JSON format. There are common attributes in the event envelope which are same across all the events, and it includes the event type, the source, and event time. The data payload will depend upon which OCI service that produced the event along with the specific event type. It defines more details, and in this example, the event was from the DevOps project for the type createProject.begin, and the resource named myTestResource was created under the given compartment and availability domain. We looked into some of the event types, and here are some of the operations that you can match and trigger a rule to run the next set of actions. For example, when a DevOps project is created, updated, or deleted, a deployment artifact is created, updated, or deleted, a code repository is created, mirrored, updated, deleted, or listed, a connection is created, updated, or deleted, a deployment environment or the target environment is created, updated, or deleted, a build pipeline or a build pipeline stage is created, updated, or deleted, a build run execution is created, updated, or deleted, a trigger is created, updated, or deleted, a deployment pipeline and a deployment pipeline stage is created, updated, or deleted, and finally a deployment is created or updated. Let's now look into rules, which is another key concept of the event service. Rules are defined as OCI objects, and to interact with the event service, you should always create and manage rules. Rules are the configuration that would allow you to select which event types to be monitored. Secondly, which particular resource or resources are to be filtered and to be monitored. And finally, automatically trigger one or more actions when those events occur. So to create a rule, you would specify a name for the rule and the compartment where you want it to be created. Rules are supported for nested compartments, so if you want to set up a tenancy-wide rule, you could create a rule in the root compartment. The next step is the trigger condition, which is the event types along with any other property filters, like you could filter using tags or any other condition criteria. For example, a condition where if an object storage bucket has been deleted that has a tag production don't delete. The response action is about what to be executed once the trigger condition has been met. You can have multiple actions for each rule. For example, you can choose to notify a user on a Slack channel through the notification service and also trigger a function call that will execute the backup scripts. OCI Events Metrics enables you to monitor performance of your rules by using metrics and alarms of the monitoring service. The events metrics measure the success of those rules you have created with matching the patterns delivery, the quality and scope of the emitted events in your tenancy. For each rule, there are 3 key metrics: the total number of events that were matched by that rule, how many were successfully delivered into the corresponding actions, and also the failed deliveries by a rule. You can also view these metrics in the telemetry dashboards and see how the rules are behaving. You can also view the total number of events that were emitted by all resources in an entire compartment. Here is an example with an end-to-end workflow of the event service with an action. We start with the request to provision an Oracle Autonomous Transaction Processing Database instance, and once the provisioning succeeds, a create instance and event is received by the event service. Now a rule has been created on that event, which then triggers an action to invoke or pull functions. That function contains the logic to run scripts to create schemas and tables and import the golden data into the newly provisioned ATP instance. At the same time, another action is triggered through the notification service, which both sends an email to an administrator as well as creating a PagerDuty incident. We will now look into some of the core use cases of the event service. Automate cloud operations. As a DevOps engineer, you can automate the end-to-end provisioning workflows or use automation for your scaling requirements or for securing and tagging of cloud resources. Simplify cloud governance. By integrating events with other services like OCI functions, you can better protect the entire cloud infrastructure estate. You can use functions for creation and deletion of an instance that violate security guidelines or use it for updating the route tables, security list, etc. Build event-driven microservices and serverless applications. You can also use event service with functions for a faster event-driven serverless application development. Gaining insights into security operations. Security operations can use events with services like streaming to route events to security incident management systems for deeper analysis. To wrap up, we looked into the key concepts of event service, the event types of DevOps, creating rule conditions, and an end-to-end workflow with provisioning an ATP instance. So that's all in this lesson. Thank you for watching. Welcome to this demo on event service. With using event service, you can subscribe Welcome to this demo on event service. With using event service, you can subscribe to changes happening to your cloud resources and then respond to them by using Oracle functions, notifications, and streaming. In this demo, we will be looking at a few events emitted by the DevOps service and create a set of actions. I have logged into the OCI console. To navigate into the service, click on the top left icon, Observability and Management, and then Event Service. Rules are one of the core concepts of the service, and it helps you to trigger actions for a set of selected event conditions. Let's create a rule. Provide a display name, a short description for the rule. Under the rule conditions, we will use event type as the condition. There are service names that you can choose from the list, and here let's choose the DevOps deploy. There are several event types for the DevOps deploy, like you can create rule for the deployment artifact or deployment environment. Let's use the deployment create for an app deployment. And in the same way, you could add more conditions for different event types, which are usually occurring in a complex infrastructure environment. Under the actions, we will create two sets of actions, one with functions and another with notification. So let's choose functions. I have configured a function that will create an object storage bucket and upload a text file into the bucket. We are not covering the specifics of that function that we are using here, but you can always refer to those respective lessons to get started with function. So let's proceed to choose the compartment where we have the functions created. Choose the function application which we want to run, and then choose the function. So when the app is deployed with creating an event for the deployment create, this function should be invoked to create an object storage bucket along with uploading a text file into the bucket. Let's add one more action to create a notification and choosing the topic that would send an email once the deployment is created. I have now created both actions, and so let's proceed to create the rule. Let's now navigate into the DevOps service and create a deployment. I have an existing DevOps project. So let's click on the deployment pipeline. We will deploy a web app service with choosing one of this pipeline. And click on Run Pipeline. The deployment would take a few minutes, so let's wait until the task is complete and get back to this page here. The status is now succeeded, which means the web app service have been deployed, and this should notify as an email. So let's log into the account and look for a notification. The following email has been notified, and we can see the resource has been created. The next action was to invoke a function, and we selected a function that will create an object storage bucket, which will then upload a text file. So let's navigate to the storage service and then object storage buckets. The new bucket is created by the function, and we can also see the file also have been uploaded into the bucket followed by the event. Let's now navigate back to the rules page of the event service. The rules page also provides you metrics to monitor the performance of the event service. For example, you can monitor the total number of events that were delivered to actions, the total events that were not delivered to actions, and finally, the number of events matched by the rule. So that's all in this demo. We looked into creating a rule condition for the DevOps deployment and also triggering actions with Oracle functions and notifications. Thank you for watching.